I know that you've been terribly impressed with the quality of my drawings on the board and on the paper throughout the semester, but my artistic skills are not sufficient for this topic, so I'm turning to a web application called StatCrunch for this. And what we're doing here is we're looking at a population. Okay, this gray area is a population, and it's bell-shaped, says so up here. The mean is 25 and the standard deviation is 5. That's by design. We could change those if we wanted to. No need for us to. Now what we're going to do is we're going to take some samples from this population. I'm going to take samples of size 4, not size 2. And we're going to calculate the mean of the sample that we choose, and then we're going to record it down here in our distribution of sample means. That's what this video is all about, is the distribution of sample means. All right, we're starting by taking samples, calculating the mean, and we're going to look at how those are distributed. Now here's an animation of how this works. We grab 4 things, calculate the mean, and record it down here in our distribution. Do it again. Take the average, record it. One more time. Okay. Let's do that 5 times in a row. So we repeatedly take samples of 4 at random, calculate the mean, and record that, and we want to see how those are distributed. Now notice our sample means down at the bottom of the screen are a little denser than the distribution itself was. I'm going to do that 1,000 times. Boom. 1,000 more times. Okay, so here's how our population is distributed. Sort of between 10 and 40 here. But if we take samples of size 4 and record their means, the means are distributed a little bit differently. They sort of have the same measure of center, right? Our population had a mean of 25. Our sample distribution has a mean of 25, so the center is in the same place. But look at our standard deviation. Standard deviation up here is 5. That's our population. Standard deviation of the distribution of the sample means is 2.5. That's half as much, half as spread out, so much more compact. Now what happens if we take a bigger sample? Let's take a sample of, let's say, 25. And we take our, boom, take our 5 samples there, another 5. Let's jump right to 1,000. Another 1,000. So we took 2,000 samples, each of size 25, and graphed the distribution of those sample means. Our population hasn't changed. We get a mean of 25 and a standard deviation of 5. But check out our distribution of sample means. A mean of just about exactly 25 and a standard deviation of just about 1. Okay, so when I had a sample size of 4, I had a standard deviation here that was half of the standard deviation of the population. I increased the sample size to 25, and now the standard deviation is 1/5 that of the population. So what we're getting for distribution of sample means is a normally distributed distribution with the mean exactly the same as the population, exact in air quotes, you can't see that, and a standard deviation that's equal to the standard deviation of the population divided by actually the square root of the sample size. Right? Square root of 25 is 5. This standard deviation is 1/5 that of the population. Okay, so the distribution for sample means has a mean that's equal to the mean of the population and a standard deviation that's equal to the population standard deviation divided by the square root of the sample size. Now, you might think that that works out only because the population has a normal distribution. Let's take a look at a different distribution. This one, right skewed, should be similar to our exponential distribution that we looked at earlier in this unit. There we go. Very similar to the exponential distribution. The little green arrow down here is the mean at 14. Tells us right here. The median's at red. We don't care about that. And let's do our sample size of 4 again. And let's just run to doing that 5 times first, and then we'll go to 1,000. We're more likely to get things from the lower end of this population because it's not symmetric. Okay, that's 5. It looks like they're clustering right around the mean of the population, so that's good. We do it a couple thousand times, and we end up with a normal distribution, give or take, with a mean that the population was at 14. Our distribution's at 13.7. That is almost exactly the same. A little bit farther off than it was last time. Our standard deviation was about 12, and the standard deviation of our new distribution is about half of that, 6. So that's 12 divided by the square root of 4. So that holds. Okay, so this is the distribution for sample means and the central limit theorem, which we're going to talk about next time. That when you take samples of size n, here n is 4, when you take samples of size n from a population, the distribution of those sample means has a mean, it's normally distributed, its mean is the same as the mean of the population, and its standard deviation is the standard deviation of the population divided by the square root of the sample size. Now the implications of that we're going to look at next time, but it's important that we understand that. I will see you for the last video I have to make for this course in about 5 minutes my time.